Hi, my name is Sai, and this is Sai's Science Show. It's been a while since the last science episode, and we're glad to be back. My guest, and also my mom, is Anu.
Hi, Sai. I'm really thrilled to be invited on the show.
Well, we have a really exciting episode today. In fact, the mood around here is electric. We're talking about electromagnetism.
Wow, Sai. I've always wanted to understand electromagnetism better. I learned a little in your first episode where you talked about the composition of atoms, and you also talked about the Hadron Collider.
I'm glad you remembered that because it will come up again. First, we're going to talk about the principles of electromagnetism, and next we're going to talk about some of the applications of electromagnetism. By the way, an application of science or an applied science is different from a pure science. A pure science is the thought of it and only the thought of it. It's pure. Applied science is when you put on the thought to use in the world.
Got it. Where should we start? Actually, maybe first you should tell us what electromagnetism is.
Electromagnetism is a force that uses magnetism with electricity. It is also a force between electrically charged particles. The way electromagnetism works is basically like magnetism. In magnetism, a metal is attracted to a magnet. In electromagnetism, the two things that are attracted to each other are electrically charged. They could be magnets or they could be atoms.
Is that the cause of static shock? You know, like when you touch something and you feel a sting and sometimes see a spark?
That's a good example. Static shock is actually an imbalance between positive and negative charges. But this is the pure science. Let's talk about some of its applications.
How can you, quote-unquote, apply electromagnetism? It seems a little complicated because if you've already added electrical charge to a situation where there's magnetic attraction, it's not really, quote-unquote, pure anymore, is it?
That's a good question, and it is complicated. Albert Einstein ended up developing entirely new theories about light and matter from studying electromagnetism. One of the things he studied is how something could be part and whole at the same time, like light being both a particle and a wave. That idea is important in electromagnetism because of the electromagnetic field.
I seem to remember doing experiments with iron filings when I was in school. We would put these iron filings, which are small flakes of metal, in between two magnets. They would all line up, showing the direction of the magnetic field.
Exactly. With an electromagnetic field, it affects the behavior of charged objects in the field.
Objects meaning atoms?
Sort of. Imagine if you run an electric current through a wire. It creates an electromagnetic field around the wire. You can control the amount of magnetic power in the wire by increasing or decreasing the amount of electric current.
I guess you can shut off the magnet by shutting off the electricity.
That's right. And you mentioned the Hadron Collider, which uses a giant electromagnet to study how atoms behave in this field.
Sai, what are some of the applications of this?
Well, a lot happened with the invention of vacuum tubes. These are glass tubes either filled with gases or air taken out. To help control the flow of electrons moving in an electromagnetic field, they help to amplify current.
Your dad has an amp for his electric guitar. Are those glass tubes in the back what you're talking about?
Yes, the electricity from the guitar goes to the amplifier, and the vacuum tube, quote-unquote, tells the electricity to amplify the volume of the guitar.
Well, I also remember seeing a bunch of vacuum tubes on the back of the ENIAC when we visited it in Philadelphia.
That's very important. The ENIAC was the first computer. It stands for Electronic Numerical Integrator and Computer. Remember that professor who explained it to us? He said that every time you use a switch on a panel of the ENIAC, the vacuum tubes take the electricity and amplify it.
Yes, so with a small electromagnetic field, you could run something at the scale of a computer.
That's right. Professor Schaefer told us the ENIAC took up a whole building at the University of Pennsylvania. But even though that seems big to us now, it was small compared to the work the computer was doing, in other words. It's cool that you can still visit the ENIAC. The way it is designed, you can actually see its parts and how it works. It's sort of like the insides of a computer. You can see its panels, its vacuum tubes, and it doesn't have a screen that hides those things.
Sai, this is so interesting. It's amazing that these things come from the principles of electromagnetism.
In other words, they apply science. Well, that's all the time we have today. Thanks for coming on the show, Anu. I hope you learned something.
Yes, I did. I learned about
Science. Look out for the next episode of Science Show.